First of all, let's draw a diagram. This question 16 from exercise 6c. Let's draw a diagram. So we have a, that's the floor. The height of the player is 2 meters. The ball is thrown at the initial speed u. The angle is 40 degrees. It hits the button at the distance, horizontal distance 10 meters away from the player. So the trajectory of the ball hits it somewhere, and we know that the vertical height of the basket is 3.05 meters. Now, if you draw the line across, you can see that this vertical distance is 3.05 meters. Take away 2 meters, it's 1.05. We need to do this because, remember, we're going to measure all the distances, all the displacements from the point of projection O. Okay, what else can we add to our diagram? Maybe the vertical axis Y going up, reminding us that that's our positive direction, and acceleration G is down. I think that's it. So we'll put all the information on our diagram. Now, time to think how to approach the question. We need to find the speed with which the basketball is thrown. So it means that we are interested in the initial speed. What are we given? We're given the horizontal displacement and we're given the vertical displacement. And because it's about the displacement, it's the displacement that we're given, clearly we're going to use this equation, S equals ut plus half at squared. It will be helpful, definitely, because it's all about displacement, initial velocity that we don't know, time and acceleration. But again, at least we know this bit and we know this bit. And because we can write down two equations, one for the horizontal displacement and one for the vertical displacement, we can figure out two unknowns then, time and initial velocity. Okay, let's do it. Let's start horizontally. So what do we have in horizontal direction? The displacement is 10 meters. The initial velocity horizontally is u cos 40, and we multiply it by t, and that's it. So that's equation number 1. What do we have vertically? Vertically, displacement is 1.05 up. Vertical component of the initial velocity is u sine 40 multiplied by time. Then we have minus half g t squared. So that's equation number 2. That's it. We are interested in u. So our aim is then to eliminate t from these equations and get the expression, get the equation for u. If we take the first equation, we can rearrange it for t to get 10 over u cos 40. That's it. And now let's substitute it into the second equation to get 1.05 equals u sine 40 times 10 over u cos 40. Don't rush, do it all, step by step carefully, because quite a lot of calculations here and quite a lot of manipulations with the terms and equations. So half g, and it's 100 over u cos 40 all squared. Right, let's simplify it. 1.05 still on the left hand side. Here what can we see is U is at the top, U is at the bottom, cancelled. Sine 40 over cos 40 is tan 40. So here is 10 tan 40 minus half G is 4.9, and we have 100 at the top, U squared and cos squared 40 at the bottom. Let's take this term, take it over on the left hand side to make it positive. So it's 490 over U squared cos squared 40 equals tan 40 minus 1.05, which gives us 490 over U squared cos squared 40 equals 7.34. So U squared is 490 over 7.34 divided by cos squared 40. Now we can work out U squared and U as well. So the value of U is 10.67, just 10.7 meters per second to 3 significant figures. Again, it makes sense to take 2 significant figures because G is given to 2 significant figures. It's more sense here to give the answer as 11 meters per second. The 2 significant figures. Good. So that's part A, and part B is 2 assumptions. What can be ignored here? If you model the basketball as a particle, clearly, if it's a particle, the size is ignored. Always state this, and I would say any rotational motion of the basketball is ignored as well, because it can affect the direction of motion, some rotation of the ball, and it won't be parabola like this we considered. I don't agree with the textbook. They stated that the weight is could be neglected as well. No, the weight is there. So the mass of the ball is there. We don't make any assumption that it's light, that it weighs nothing. If it's a particle, it's the size which is ignored and rotational motion which is ignored. That's it.